Hello, in this lecture we will find out the radius of the biggest circle. In the drawing we have 4 circles. 3 circles are inside the biggest circle. The radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units. The radius of the smallest circle, this circle, is equal to 1 unit. And we want to find out the radius of this circle, that is actually the biggest circle. So, first of all, I will explain you 2 terms. Actually, when 2 circles are tangent to each other, there are 2 types of tangency. The first type of tangency is the internal lunge. Here, those 2 circles are tangent to each other internally. Here, point S is the point of tangency between those 2 circles, that is to say, those 2 circles touch each other at point S. So S is the point of tangency, and the center of the big circle is at point O, and the center of this small circle is at point N. And the distance between the centers of those circles is OM, and OM equals to OS minus MS. Again, OM equals to OS minus MS. So OS is equal to capital R, that is the radius of the big circle, and MS equals to small r, that is the radius of the small circle. That is to say, the distance between the centers of 2 circles that have an internal lunge between them is the difference between the lengths of the radii. In this case, it equals to OM. The distance between the centers is equal to capital R minus small r. Okay, so whenever you have an internal lunge between 2 circles, then the distance between the centers of those 2 circles is the difference between the lengths of the radiuses. In this case is capital R minus small r. The second type of tangency between 2 circles is the external lunge. In this case, the 2 circles are tangent to each other externally. The point of tangency is at point S. That is to say, they touch each other externally at point S. And the distance between the centers of those 2 circles, that is to say OM, will be equal to capital R plus small r. Again, the distance between the centers of 2 circles that have an external lunge between them is the sum of the length of the radii. In this case, it's capital R plus small r. Okay, so now we will solve the question. We find out the radius of this, the biggest circle. So here we will define the center of, actually we know that the center of this circle, the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the radius of this circle is equal to 1 unit. And we want to find out the radius of the biggest circle, that the 3 other circles are inside the biggest circle. So we'll define the center of this circle as point A. We'll define the center of this circle as point B, and we'll define the center of this circle as point C. Here I didn't mention that we have here this line. It is actually tangent to this circle at point D. Point D is the point of tangency of this tangent with this circle, and this tangent, that is the straight line, is tangent to this circle. At this point we will define the point of tangency of this tangent with this circle as point E, and this tangent is tangent to the smallest circle. At this point we will define the point of tangency with this tangent and the smallest circle as point F, and we have we will join together points A and D by a straight line. Actually, line segment AD is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point A and ends at point D. That is a point on this circle itself, therefore it is the radius of this circle. That is to say, we know that the radius of this circle is equal to 4 units, so it equals to 4 units. And we will first of all, so this is the radius, AD is the radius of this circle that equals to 4 units. We will join points B and E together by a straight line. BE is the radius of this circle because of the fact that it starts from the center of the circle and ends at point E. That is a point on this circle itself, therefore it is the radius of this circle. That is to say, it equals to 9 units. And we join point C and F together by a straight line. CF is also the radius of the smallest circle because of the fact that it starts from the center of the circle and ends at point F. That is a point on this circle itself, therefore CF is the radius of this circle, that is to say it equals to 1 unit. And we also have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius. Drawn to its point of tangency. I'll read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here we have the radius AD. The radius AD is drawn to the point of tangency, that is to say, is drawn to point D, that is the point of tangency of this tangent, if this circle. Therefore, according to rule number 1, this tangent will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius BE that is drawn to the point of tangency, that is to say, it is drawn to point E, that is the point of tangency of this tangent with this circle. Therefore, the tangent DE will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, here in the smallest circle, we have the radius CF that is drawn to the point of tangency, that is to say, it is drawn to point F, that is the point of tangency of tangent DF with this circle. Therefore, the tangent DF will be perpendicular to this radius CF, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And here we will define the radius, we will define the center of the biggest circle, that is to say, the center of this circle is point O, and first of all, we will draw perpendicular from point A to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point between the perpendicular from point A to BE is point S. From point O, we go perpendicular to DE. We define the touching point between the perpendicular from point O to DE is point M. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will join together points A and B by a straight line. So here we will go perpendicular from point A to OM. So this is the perpendicular, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from point A to OM is point P. So if we focus on quadrilateral APDM, in quadrilateral APDM, this quadrilateral, we have 3 right angles, 1, 2, 3. I write it down. In quadrilateral APDM, we have 3 right angles. So in quadrilateral ADMO, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees. The sum of those 3 right angles is equal to 270 degrees, plus the size of the 4th angle, that is actually angle ADP, this angle, So the sum of the four angles inside quadrilateral APDM must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees. We will subtract 270 degrees from this equation, and we get that the size of angle ADP is equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle ADP is a right angle. That is to say it equals to 90 degrees. So we can write here that angle ADP is a right angle, so equals to 90 degrees. So actually quadrilateral APDM is four right angles. All of its angles are right angles. Quadrilateral ADPM is four right angles. Therefore, quadrilateral APDM is a rectangle. Quadrilateral APDM is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PM. AD equals to PM. But we know that AD is the radius of this circle, that is to say it equals to 4 units. We know that AD equals to 4 units. So from this equation 4 equals to AD equals to PM, we will conclude that PM also equals to 4 units. PM equals to 4 units. So we can write here that PM equals to 4 units. Okay, and here we know that quadrilateral PMES has three right angles. This quadrilateral PSEM has three right angles, and I will not repeat on the same process as we did in this quadrilateral. So from the fact that this quadrilateral has three right angles, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, it means that the fourth angle must be equal also to 90 degrees. So quadrilateral PMES is a rectangle. Quadrilateral PSME is a rectangle. And We know that the opposite sides of a rectangle are equal to each other. That is to say, DM is equal to SE, but here PM equals to SE, but PM equals to 4 units, therefore SE will be also equal to 4 units. And in the next step, we will focus on the right triangle ABS. First of all, what is the length of AB? The length of line segment AB. Those two circles have an external lunge between them. This circle that has this circle that is radius is 4 units has an external lunge with this circle that is radius is 9 units. So two circles that have an external lunge between them, then the distance between the centers of those circles, that is to say AB, will be equal to the sum of the lengths of the radii. That is to say, it will be equal to the radius of this circle, that is to say 4 units, plus the radius of this circle, that is to say it is 9 units. So AB equals to 4 plus 9 is 13. AB equals to 13 units. And here we have already found out that SE equals to 4 units. SE equals to 4 units. And BE is the radius of this circle, and the radius of this circle is equal to 9 units. BE equals to 9 units. This is the radius of this circle. So 9 units minus 4 units is the length of BS. That is to say, BS equals to 5 units. Okay? 9 units, that is BE minus SE, that is 4 units. BE minus SE equals to BS. So BS equals to 9 minus 5, 9 minus 4, 9, that is the radius of this circle, BE, minus 4, that is SE. 9 minus 4 is 5 units. So BS equals to 5 units. So we will focus on the right triangle ABS. On the right triangle ABS, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We will get that AB squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. That is to say, it equals to BS squared plus AS squared. I repeat again, in the right triangle ABS, according to the Pythagoras theorem, PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AB square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BS square plus AS square. We have already found out that AB equals to 13 units, so AB square is 13 square. 13 square is 169. And it equals to BS square. BS equals to 5. BS square is 5 square. 5 square is 25 plus AS square. AS is the missing variable, so we leave it as it is. So in conclusion, we found out that 169 equals to 25 plus AX square. We will subtract 25 from this equation. 169 minus 25 is 144. So 144 equals to AS square. We'll take a root out of this equation and we will get that AS equals to the square root of 144, and the square root of 144 is 12. So we found out that AS equals to 12. AS equals to 12. AS equals to 12. So here ADES, quadrilateral ADES is a rectangle because of the fact that it has 4 right angles. I write it down. Quadrilateral ASED is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AS equals to DE. AS equals to DE. Here AS equals to DE. But we already found out that AS equals to 12. AS equals to DE, but AS equals to 12. So from this equation we will derive that 12 equals to AS equals to DE. We will derive that DE also equals to 12 units. So we can write here that DE equals to 12 units. Here we will define ME, line segment ME as X. So if ME equals to X, then DM equals to DE minus ME. DM equals to DE minus ME. That is to say, it equals to 12 minus X. And because of the fact that quadrilateral PSME is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to PS. In rectangle, DSME ME equals to PS. This is actually PS ME. In rectangle PS ME, ME equals to PS. ME equals to PS, but we know that ME equals to X according to our definition. So from this equation, X equals to ME equals to PS, we will derive that PS is also equal to X. So we can write here that PS equals to X. And again here, APDM is a rectangle. APDM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So APMD is a rectangle, and the opposite sides of this rectangle are equal to each other. That is to say, DM is equal to AP. DM is equal to AP. But DM is equal to 12 minus X. We already found out that DM equals to 12 minus X. So from this equation, 12 minus X equals to DM equals to AP, we will derive that AP also equals to 12 minus X. AP equals to 12 minus X. In the next step, we will focus on the right triangle APO. So I will draw the right triangle APO in a new page. So we'll focus on the green triangle APO. I will draw it in the new page. we will define OM as y, that is to say OM equals to y according to our definition. So OM equals to y. Here the green triangle, in the right triangle, triangle APO. So here OM is equal to y and PM equals to 4, therefore PO or OP will be equal to OM minus PM. Again, OM minus PM is equal to OP. So OP is equal to OM minus PM. That is to say OM equals to y, PM equals to 4. Therefore OP is equal to y minus 4. OP equals to y minus 4. And what is the value of AO? O is the radius of the biggest circle, that is to say it equals to capital R. According to our definition, I'll write it here. The radius of the biggest circle that we are looking for is equal to capital R. So according to our definition, the radius of the biggest circle equals to capital R. A is the center of this circle, that is to say it equals to 4 units. And the distance between the two centers A and O, here we have an internal lunge between those two circles. Here you can see that we have an internal lunge between those two circles. They touch each other internally. Therefore AO will be equal to the difference between the lengths of the radiuses. The length of the radius of the big circle is R, and the length of the radius of this circle is 4. Therefore the difference between the two radiuses is R minus 4. R minus 4. So according to the Pythagoras theorem, in the right triangle, triangle AOP, here, the green right triangle, triangle AOP, by Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say AP square plus OP square equals to AO square. This will be equation number 1. AP equals to 12 minus x, therefore AP squared is 12 minus x squared plus OP equals to y minus 4, so y minus 4, OP squared is y minus 4 squared, and it equals to AO squared. We already found out that AO equals to R minus 4, AO equals to R minus 4. So if AO equals to R minus 4, then AO squared will be equal to R minus 4 squared. So according to equation number 1, 12 minus x squared plus y minus 4 squared equals to R minus 4 squared. Here we will open the brackets on both sides of this equation, and we get that twelve minus x squared is 144 plus x squared minus 24x plus y minus 4 squared is y squared plus 16 minus 8y, that equals to r minus 4 squared. R minus 4 squared is r squared minus 16 minus 8r. Here we have 16, it's actually r squared plus 16. So we have 16 on both sides of the equation, so 16 will get cancelled. So here we will add 8r to this equation, and we will get that, and we'll subtract 144 and we will add 24x, or we will subtract 8r to this equation. Actually, we will add 8r to this equation, and we will get that r squared equals to 8r minus 8y plus 144 plus x squared plus y squared minus 24x. Here we will subtract x squared and y squared from this equation, and we will get that according to equation number 1, r squared minus x squared minus y squared equals, we will take a common factor of 8 out of those two expressions, so it will be equal to 8r minus y plus 144 minus 24x. We'll write it again. According to equation number 1, r squared minus x squared minus y squared equals to 8r minus y plus 144 minus 24x. I'll repeat again, according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Okay, so in the next step we will draw perpendicular from point O to BS. So I will draw, we will define the touching point between the perpendicular from point O to BE as point T. So I will draw it in a new page. So we'll have the right triangle, triangle OBT. Here triangle OTME, actually quadrilateral OMET has 3 right angles, therefore the fourth angle must be also equal to a right angle, therefore actually quadrilateral OTEM is a rectangle, that is to say the opposite sides of it are equal to each other. So OM is equal to OT. So here OT, but we know that OM equals to Y according to our definition, so OT will be also equal to Y. It is actually ET will be equal to Y. And we know that PE equals to, actually OT will be equal to here OE t equals to x, because of the fact that the opposite sides of a rectangle are equal to each other. So here in the right triangle, triangle OBT, OT equals to x. And what is the value of OB? The value of OB, it is actually the distance between the centers of the biggest circle, that is R, and this circle, that is 9. So, and we have internal knot between them. Here they touch each other internally, so it will be equal to the difference between the radiuses. That is to say, it will be equal to R minus 9. So here we can write down that OB equals to R minus 9. And what is the value of BT? The value of this line segment? We know that OM equals to TE equals to Y. So here BE equals to 9 units. Okay, BE equals to 9 units because it is the radius of this circle. So BE minus TE, BE minus TE equals to BT. So you can see it here. BE, that is the radius of this circle, that equals to 9 units, minus TE, that equals to Y, equals to BT. So here BT equals to BE, that is 9, minus TE, that is Y. So BT equals to 9 minus Y. So we will use the Pythagoras theorem on the right triangle OBT. On the right triangle OBT, we'll use the Pythagoras theorem. Okay, according to the Pythagoras theorem, in the right triangle, triangle OBT, the square of the hypotenuse, that is OB, so it is the square of the hypotenuse is OB square, will be equal to BT square plus OT square. So OB is R minus 9, so OB square is R minus 9 square, and it equals to BT square, that is 9 minus Y square, plus OT square is X square. Okay, so here we'll open the brackets on both sides of equation number 2, and we'll get that r minus 9 squared is r squared plus 81 minus 18r and it equals to 81 plus y squared minus 18y plus x squared. Here we have 81 on both sides of the equation, so 81 will get cancelled. So from this equation, equation number 2, we'll get that r squared minus x squared minus y squared equals to 18 r minus y. So according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. Here, according to equation number 1, 12 minus x squared plus y minus 4 squared equals to r minus 4 squared. So here we actually, I'll check here that I didn't make any mistake. 144 plus x4 minus 24x plus y squared plus 16 minus 8y equals to r squared plus 16 minus 8r. So here we have r squared that equals to 8r minus 8y plus 144 minus 24x, so r squared minus x squared minus y squared equals to 8r minus y plus 144 minus 24x. So equation number 1 is correct, equation number 2 is also correct. So we'll continue. In the next step, we will draw perpendicular, but first of all, we will join points B and C together by a straight line. B is the center of the radius of this circle, that is radius is 9 units. C is the center of the smallest circle, that is radius is equal to 1 unit. And we have an external lunge between those two circles. And in case of an external lunge, the distance between the centers of those two circles, that is to say BC, will be equal to the sum of the radiuses of the two circles. The radius of this circle is 9 units. The radius of this circle is 1 unit. 9 plus 1 is 10. So BC equals to 10 units. BC equals to 10 units. Here we will draw perpendicular from point C to BE. quadrilateral, so we will define the touching point between the perpendicular from point C to BE as point Q. QECF, we will focus on quadrilateral QECF. QECF has 4 right angles. Quadrilateral QECF has 4 right angles. The sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, 3 right angles, the sum of 3 right angles is 270 degrees. So the fourth angle, this angle QCF, must be equal to 90 degrees in order to complete the sum of the angles in quadrilateral QECF to 360 degrees. So because of the fact that quadrilateral QECF has 4 right angles, quadrilateral QECF is a rectangle. Okay? I write down the conclusion that quadrilateral QCEF is a rectangle. And because of the fact that quadrilateral QECF is a rectangle, we know that the opposite sides of a rectangle are equal to each other. That is to say, CF is equal to QE. CF is equal to QE. It is very difficult to see here the drawing. Okay. CF is equal to QE, but CF is the radius of the smallest circle. That is to say, it equals to 1 unit. From this equation, Q1 equals to CF equals to QE, we will derive that QE also equals to 1 unit. QE equals to 1 unit, so here QE equals to 1 unit. So we know that BE is the radius of this circle. The radius of this circle is equal to 9 units, so BE equals to 9. BE minus QE is equal to EB. BE minus QE is equal to EB. That is to say, EB equals to BE, that is the radius of this circle, that equals to 9 units, minus QE, that equals to 1. 9 minus 1 is 8. EB equals to 8. EB equals to 8. EB equals to 8 units. And BC equals to 10 units. So we'll focus on quadrilateral BQC, on triangle BQC. In triangle BQC, in quadrilateral triangle BQC, the right triangle BQC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BC square will be equal to CQ square, that is the missing variable, plus QB square. plus QB square. Actually, QB is equal to 8 because it is 9 minus 1. QB equals to 8 units. So here BC equals to 10. BC square is 10 square, 10 square is 100, equals to CQ, that is the missing variable, so we leave it as it is, CQ square plus QB equals to 8 units. So 8 QB square is 8 square, 8 square is 64. We subtract 64 from this equation and we'll get that CQ square equals to 36, that is to say CQ equals to 6 units. So here CQ equals to 6 units. CQ equals to 6 units. And we have already found out that quadrilateral QEFC is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say QC is equal to EF. QC is equal to EF. But we just right now found out that QC equals to 6. So from this equation QC equals to 6 equals to EF. We will derive that EF also equals to 6 units. EF equals to 6 units. In the next step, we will draw perpendicular from point C to OM. Okay. We define the touching point between the perpendicular from point C and OM as point U. So this angle equals 90 degrees, this angle equals to 90 degrees. So quadrilateral UMFC has 3 right angles, and according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, the fourth angle, that is to say angle UCF, must be equal also to 90 degrees. So quadrilateral UMFC is a rectangle, and I will write it down. Quadrilateral UMCF is a rectangle. The opposite sides of a rectangle are equal to each other. That is to say MF equals to UC. MF equals to UC. MF equals to x plus 6. As you can see here, MF equals to x plus 6. From this equation, we will derive that UC also equals to x plus 6. UC equals to x plus 6. So, what is the value of UC equals to x plus 6? What is the value of UO? UO will be equal to OM minus UM. UO equals to OM minus UM. Again, UO equals to OM minus UM. UO equals to OM minus UM. OM equals to Y according to our definition. OM equals to Y according to our definition. UM, here UM, according to the rule that the opposite sides of a rectangle are equal to each other, in rectangle UMFC, the opposite sides UM and CF are equal to each other, and CF equals to 1, so UM also equals to 1. So UM equals to 1. So UO equals to Y minus 1. UO equals to Y minus 1. UC equals to X plus 6. And what is the value? We join points O and C together by a straight line. So, what is the value of OC? OC, O is the center of the biggest circle, and the radius of the biggest circle is capital R according to our definition. C is the radius of the smallest circle, and the radius of the smallest circle equals to 1 unit according to what is given us in the question. So therefore OC, and we have an internal lunge between the biggest circle and the smallest circle. We have an internal lunge, and whenever we have an internal lunge between two circles, then the distance between their centers will be equal to the difference between the lengths of the radiuses. And the length of the radius of the biggest circle is equal to R, capital R. The length of the radius of the smallest circle is equal to 1. That is to say, the distance between the centers of the biggest circle and the smallest circle equals to R minus 1. So OC equals to R minus 1. Okay, in the next step, we will focus on the right triangle OUC. Triangle OUC is a right triangle. We will focus on the right triangle OUC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I write it down. We will focus on the right triangle OUC. In the right triangle OUC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OC. So the hypotenuse OC equals to R minus 1, and the square of the hypotenuse will be equal to R minus 1 square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OU square. OU is Y minus 1, so OU square is Y minus 1 square plus UC square. UC is X plus 6, Therefore, UC squared is x plus 6 squared. Okay? So, we created here three equations with the variables r, x, and y, and we have to solve those three equations. We have three equations with three variables r, x, and y. We will solve the three equations and we will get the value of capital R, that is the radius of the biggest circle. Actually, first of all, we will develop equation number 3. Here, equation number 3, we will open the brackets on both sides of equation number 3, and we will get that r minus 1 square is r square plus 1 minus 2r, and it equals to y square plus 1 minus 2y plus x square is x square plus 36 plus 12x. So here we get that, according to equation number 3, r square, we subtract x square and y square from equation number 3, so minus x square minus y square will be equal to, here we have 1 in both sides of the equation, so 1 will get cancelled. So we will add 2r to this equation. It will be 2r. Here we will take 2 as a common factor of those two expressions. So here we will have 2r minus y plus 36 plus 12x. I repeat again. We got that r square minus x square minus y square equals to 2 times r minus y plus 36 plus 12x. So this is equation number 3. And we have also equation number 2. According to equation number 2, we have already found out that r square minus x square minus y square equals to 18 r minus y. And we have also equation number 1. We have already found out that according to equation number 1, according to equation number 1, r square minus x square minus y square equals to 8 times r minus y plus 144 minus 24x. So here we will compare between equation number 1 and equation number 2, and we will get that this will be equation number 4. We will compare between equation number 1 to equation number 2, and we will create equation number 4. according to equation number 4, eight times r minus y plus 144 minus 24x equals to 18 times r minus y so here compare between equation number 1 and equation number 2, and in this way we created equation number 3. So here we subtract 8 times r minus y from equation number 4, we get that 144 minus 24x equals to 10 times r minus y. Here we will divide equation number 4 by 10, and we get that according to equation number 4, r minus y equals to 144 minus 24x over 10. So here we will divide both the numerator and the denominator by 2, and we will get that it equals to 144 over 2 is 72, minus 24 over 2 is minus 12, 10 over 2 is 5. So in conclusion, we got that according to equation number 4, r minus y equals to 72 minus 12x over 5. So this is equation number 4. In the next step, we will compare between equation number 2 to equation number 3, and we will get that two times r minus y plus 36 plus 12x equals to 18 times r minus y. We subtract 2 times r minus y from equation number 3. And from equation, actually, we compared equation number 2 to equation number 3, and in this way we created equation number 5. So this will be equation number 5. So we'll subtract 2 times r minus y from equation number 5, and we will get that 36 plus 12x equals to 16 times r minus y. Here we will divide equation number 5 by 16, and we will get that r minus y equals to 36 plus 12x over 16. Here we will divide both the numerator and the denominator on this side of equation number 5 by 4. And we'll get that 36 over 4 is 9, plus 12x over 4 is 3x, 16 over 4 is 4. So in conclusion, we found that according to equation number 5, r minus y equals to 9 plus 3x over 4. But we have already found out that according to equation number 4, r minus y equals to 72 minus 12x over 5. So we will compare equation number 4 to equation number 5, and we will get that 72 minus 12x over 5 equals to 9 plus 3x over 4. So this will be equation number 6. We will cross multiply equation number 6. We'll cross multiply equation number 6, and we will get that 4 times 72 minus 12x equals to 5 times 9 plus 3x. This is equation number 6. We'll open the brackets on both sides of equation number 6. Two times 72, 2 times 72 is 288. Minus 4 times minus 12 is minus, actually 12x. 2 times minus 12x is minus 48x, equals to 5 times 9 is 45, 5 times 3x is 15x. So according to equation number 6, we'll subtract 45 from equation number 6. So here we get 243 equals to 63x. So x equals to 243 over 63. So here we will 243 is actually, if we divide it by 7, so we divide it by 7, here 243 divided by 9. So we divide both the numerator and the denominator by 9, and you will get that 247 over 9 is 27. 63 over 9 is 7. So we found out that x equals to 27 over 7. And here according to equation number 2, we know that r, according to equation number 5, we know that r minus y equals to 9 plus 3x over 4. Here we'll subtract x by 27 over 7, and we'll get that r minus y equals to 9 plus 3 times x, and x is 27 over 7, or divided by 4. Here 3 times 27 is 81, so I write it down. So we get that only for question number 5, r minus y equals to 81 over 7. 9 times 7 is 63. And here it is times 4. So here we got that r minus y equals to 60 plus 80, 144 over 4 times 7. Here we know that 144 over 4 is 36. So we divide this equation, so 4 will get cancelled, and we will get that r minus y equals to 36 over 7. And we have equation number 4 that states that r minus y so here we have r minus y equals to 36 over 7, and so r minus y equals to 26 over 7. And we have a question number 4. So we know that r minus y equals to 36 over 7 and x equals to 27 over 7, and according to equation number 3, r minus y equals to 72 minus 12x over 5. And according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y, and we already found out that r minus y equals to 36 over 7, so we can substitute r minus y in equation number 2 by 36 over 7. We will do it now, and we will get that here r squared minus y squared is equal to r plus y times r minus y, according to the formula that, to the algebraic identity, that a plus b times a minus b equals to a squared minus b squared. So it is r plus y times r minus y minus x squared, and x is 27 over 7, so x squared is 27 over 7 squared. That equals to 18 times r minus y, and r minus y is 36 over 7. So here we get that, according to equation of number 2, r plus y, so we substitute r minus y by 36 over 7. And it equals to 27 over 7 square plus 18 times 36 over 7. So here we have comes into question number 2, r plus y times 36 over 7 equals to 27 over 7 times 27 over 7 plus 18 times 36 over 7 . Here we will multiply this equation by 7 and we'll get that according to equation number 2, r plus y times 36 equals to 27 times 27 over 7 plus 18 times 36. Here we will divide this equation by 9 and we will get that according to equation number 2, here 36 over 9 is 4, so it is 4 times r plus y, that equals to 27 over 9 is 3, so it is 3 times 27 over 7 plus 18 over 2 is 9, 18 over 9 is 2, and 2 times 36 is 72. So here we will make a common factor with those two expressions. So we will multiply 72 by 7 and then we will divide it by 7 and we will get it 4 times r plus y equals to 3 times 27 is 81 over 7 plus 7 times 72 . So here we got that four times r plus y equals to 81 and 7 times 72 is 504 over 7 . So here we got that according to question number 2, 4 times r plus y equals to 81 plus 504 is 585 over 7. Here we divide the equation number 2 by 4 and we get that r plus y equals to 585 over 28 r plus y equals to 525 over 28, and we've already found out that r minus y equals to 36 over 7. According to equation number 5. So here we will add equation number 2 to equation number 5, and we will get that r plus r is 2r, plus y minus y is 0, so 2r equals to 585 over 28 plus, we will multiply both the numerator and the denominator by 4, so we'll get 144 over 28. So 2r equals to 585 plus 144 is 729 over 28. Here we will divide this equation by 2 and we will get that the radius of the biggest circle equals to 589 over 60 over 56 units. Okay, so the radius of the biggest circle is equal to 729 over 56 units. Okay, that is the answer to the question. So in the next step, I'll summarize the lecture. So here we have here 4 circles. 3 circles are inside the biggest circle, and the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the radius of the smallest circle is equal to 1 unit. And we want to find out the radius of this circle that contains the 3 circles. Okay, first of all, I presented to you 2 terms. The first term is the internal lunge. Actually, whenever 2 circles are tangent to each other, there are 2 types of tangency. The first type of tangency is the internal lunge. Here, those two circles touch each other at point S. So this type of tangency is defined as internal lunge, and the distance between those two, between the radiuses, between the centers of those two circles, if we define the radius of the bigger circle as r and the radius of the smaller, if we define the radius of the bigger circle as capital R, and we define the radius of the smaller circle as small r, then the distance between the centers of those two circles, suppose that the center of the biggest circle is at point O and the center of the smaller circle is at point M, then the distance between the centers is MO, and MO equals to capital R minus small r. So the difference between the lengths of the radii of the two circles is the distance between the centers of the two circles that have an internal lunge between them. This is the first type of actually tangency between two circles, and the second type of tangency between two circles is the external lunge. External lunge is when the two circles touch each other externally. Those two circles touch each other at point S. So this is the external lunge, and the distance between the centers of those two circles, that is to say MO, will be equal to the sum of the lengths of the radiuses, that is to say it will be equal to capital R plus small r. So whenever you have an external lunge between two circles, then the distance between the centers of those two circles will be equal to the sum of the lengths of their radiuses. In this case, OM or MO will be equal to capital R plus small r. Then we solve the question. Here we defined the center of this circle, that the radius of it is 4 units, is point A. We defined the center of this circle, that its radius is equal to 9 units, as point B, and we defined the center of the smallest circle, that its radius is 1 unit, as point C. We defined the point of tangency between this circle and this straight line as point D. We defined the point of tangency between this circle and the straight line as point E, and we define the point of tangency between the smallest circle and this straight line as point F. And then I presented to you new rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. That is to say, we have here the radius AD of this circle is drawn to the point of tangency. That is to say, it is drawn to point D, that is the point of tangency of this tangent with this circle. Therefore, the tangent will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have here the radius BE of this circle is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency of this tangent with this circle. Therefore, according to rule number 1, the radius BE will be perpendicular, the tangent DE will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise here, we have the radius CF that is drawn to the point of tangency. That is to say, it is drawn to point F, that is the point of tangency of tangent DF with this circle. Therefore, the tangent DF will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So here we draw from point A, we draw perpendicular to BE. Okay? So this angle equals 90 degrees, this angle equals 90 degrees, and we define the touching point between the perpendicular from point A to BE as point S. So here we have quadrilateral APDM, quadrilateral A, and then actually we also drew actually perpendicular from point O to DE, so this angle equals to 90 degrees and this angle also equals to 90 degrees. We define the touching point of the perpendicular from point O to DE as point M. Then from point A we draw perpendicular to OM and we define the touching point of the perpendicular from point A to OM as point P. So here in quadrilateral APDM, this quadrilateral, we have 3 right angles, 1, 2, 3. And according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, we will get that in this quadrilateral we have 3 right angles, that is to say the sum of 3 right angles is 270 degrees, plus the size of the 4th angle, that is angle DAO, plus the size of this angle is actually angle DAP. In total, the sum of those 4 angles must be equal to 360 degrees. 270 degrees plus the size of the 4th angle must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract 270 degrees from this equation, and we got that the missing angle APD equals to 90 degrees. So this angle, showing this angle equals to 90 degrees, angle ADP. The missing angle is also a right angle. Therefore, quadrilateral APDM, quadrilateral APDM, this quadrilateral is a rectangle because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PM. Okay? In rectangle APDM, the opposite sides are equal to each other. That is to say, AD equals to PM. But AD is the radius of this circle, that is to say, it equals to 4 units. So from this equation, we will derive 4 equals to AD equals to PM. We will derive that PM also equals to 4 units. Okay? So PM also equals to 4 units. Here, PM also equals to 4 units. So here, quadrilateral ASEP is a rectangle. Quadrilateral ASEP, ASED, the big quadrilateral ASED is a rectangle. Why? Because it has 1, 2, 3 right angles. Actually, we have already found out that this angle is also a right angle, so it has 4 right angles. That is the reason that quadrilateral ASED is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So here AS will be equal to DE, but before that, what is the value of AD, the value of line segment AB? AB, A is the center of this circle that is radius is 4 units. B is the center of this circle that is radius is 9 units. And those two circles have an external length between them. Therefore, the distance between their centers will be equal to the sum of their radiuses, the sum of their radii. That is to say, it will be equal to 4 plus 9. 4 plus 9 is 13, so AB equals to 13 units. And here we know that BE equals to 9 units. And we have already found out that ES equals to 4 units. So 9 minus 4 is 5, so BS equals to 5. AB equals to 13. And we will implement the Pythagoras theorem on the right triangle ABS. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, and the hypotenuse AB is 13 units, BS equals to 5 units. So the missing angle will be equal to AS equals to the square root of 13 square minus 5 square, and the square root of 13 square minus 5 square 144 minus 169 minus 25, that is 144, so the square root of 144 is 12, so we found out that AS equals to 12 units, so AS equals to 12, but because of the fact that rectangle ABED, in rectangle ABED, the opposite sides are equal to each other, so AS equals to DE. Okay? In rectangle ADES, AS equals to DE. But we just right now found out that AS equals to 12, so from this equation we derive that DE also equals to 12. DE equals to 12, we defined ME as X, so dm will be equal to 12 minus x, and here we know that rectangle PSME ME equals to PS, ME equals to PS, but ME equals to PS, but ME equals to X according to our definition. So from this equation we derive that PS also equals to X, and in rectangle APDM, in this rectangle we know that DM equals to AP, DM equals to AP according to the rule that the opposite sides of a rectangle are equal to each other. Again, DM equals to AP, but just right now we defined DM as 12 minus X. So we know that DM equals to 12 minus X, so from this equation 12 minus X equals to DM equals to AP, we derive that AP also equals to 12 minus X. Okay, so AP equals to 12 minus X. Here AP equals to 12 minus X, and in triangle PSEM, so I will repeat again. In triangle, the right triangle ABS, according to the Pythagoras theorem, AB square equals to BS square plus AS square. AB equals to 13, so AB square is 13, square is 169, equals to BS equals to 5, so BS square is 5 square, 5 square is 25, plus AS square. AS is the missing variable. Here 169 minus 25 is 144, so we got that 144 equals to AS square. We took a root out of this equation and we found that AS equals to 12. AS equals to 12, and therefore DE will be also equal to 12 because of the fact that the opposite sides of a rectangle are equal to each other, so DE equals to 12. So here we focused on the right triangle AOP. In the right triangle AOP, we know that AP equals to 12 minus X. OA, what is the value of OA? O is the center of the biggest circle, A is the center of the circle that is radius is 4 units, so we have an internal lunge here between the biggest circle and this circle, so the distance between the radiuses, that is to say OA, will be equal to the difference between the lengths of the reducers, that is to say, it will be equal to capital R minus 4. So AO equals to R minus 4. And here we defined OM as Y, and we have already found out that PM equals to 4, therefore OP equals to OM minus PM. OP equals to OM minus PM, OM equals to Y, and PM equals to 4. So in conclusion, we found out that OP equals to Y minus 4. So in the right triangle, triangle OAP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, that is to say, the hypotenuse is AO, so the square of the hypotenuse is AO square, and it equals to AP square plus OP square. AP equals to 12 minus x, so AP square is 12 minus x square, plus OP square. OP equals to y minus 4, so OP square is y minus 4 square, and it equals to OA square. OA equals to r minus 4, so OA square is r minus 4 square. So here we open the brackets on both sides of the equation, and 12 minus x square is 144, plus x square minus 24x, and y minus 4 square is y square plus 16 minus 8y, and it equals to r minus 4 square. R minus 4 square is r square minus 8r plus 16. Here we subtracted 16 on this equation, and then we organized the equation number 1 in such a way that we got that r square minus x square minus y square equals to 8 times r minus y plus 144 minus 24x. Okay. Then we focused on the, actually we drew perpendicular from point O to BE. We defined the touching point between the perpendicular from point O to BE as point T. So here, point T. And here, we know that ME equals to OT, because quadrilateral OTME is a rectangle, and the opposite sides of a rectangle are equal to each other, so ME that equals to OT equals to x, so OT will be also equal to x. And what is the value of BT? BT equals to BE minus TE, and BE equals to 9. BE equals to 9. TE equals to y, so BE minus TE is 9 minus y, so BT equals to 9 minus y. So we implemented the Pythagoras theorem on this right triangle, triangle OBT. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OB square equals to BT square plus TO square. OB equals to r minus 9, so OB square is r minus 9 square. BT equals to 9 minus 1, so BT square is 9 minus 1 square, plus TO. TO equals to x, so TO square is x square. Okay, we open the brackets on both sides of the equation. We got this expression, then we subtracted 81 from both, we subtracted 81 from this equation, equation number 2, and we got that according to equation number 2, r square minus x square minus y square equals to 18 times r minus y. Okay. Then we know that quadrilateral QCEF here, first of all, from point C, we draw perpendicular to BE. So this angle is 90 degrees and this angle is 90 degrees. So we focused on quadrilateral QCEF. Quadrilateral QCEF has 3 right angles, 1, 2, 3. So any quadrilateral that has 3 right angles must be a rectangle because of the fact that the sum of the angles in any quadrilateral is equal to 360 degrees, so the fourth angle must be also equal to 90 degrees. So quadrilateral QCEF will have 4 right angles, and then the quadrilateral that has 4 right angles is a rectangle. That is to say, quadrilateral QCEF is a rectangle. Okay, and the opposite sides of a rectangle are equal to each other. That is to say, in rectangle QCEF, the opposite sides of rectangle QCEF are equal to each other. That is to say, CF equals to EQ. CF equals to EQ, but we know that CF is the radius of the smallest circle, that is 1 unit. From this equation, we derive that EQ or QE also equals to 1 unit. So here QE equals to 1 unit. And we know that BE equals to 9 units. QE equals to 1 unit. So BE minus QE will be equal to BQ. Okay, so BQ equals to 9 minus 1. 9 minus 1 is 8, so we found out that BQ, here, PQ or QB equals to 8 units. Here, QB equals to 8 units. We join together points B and C by a straight line. We focused on the rectangle, on the right triangle BQC. On the right triangle BQC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BC square equals to CQ square plus QB square. And what is the value of BC? B is the center of this circle. The radius of this circle is 9 units. C is the center of the smallest circle, and the radius of the smallest circle is equal to 1 unit. And here we have an external length between those two circles, and whenever we have an external length between two circles, then the distance between radiuses will be equal to the sum of the lengths of their radiuses. That is to say, the distance BC between the centers of those two radiuses, the distance between the centers of those two circles, that is to say BC, will be equal to the sum of the lengths of the radiuses. That is to say, it will be equal to 9 plus 1, that is to say, it equals to 10 units. So the hypotenuse BC of the right triangle BQC equals to 10 units, BE equals to 8, and so CQ is the missing variable. So BC square equals to CQ square plus QB square. BC is 10, so BC square is 10 square, 10 square is 100, and it equals to CQ square plus QB is 8, so 8 square is 64. 100 equals to CQ square plus 64. We subtracted 64 from this equation, and we got that CQ square equals to 100 minus 64 is 36. CQ square equals to 60. CQ square equals to 36. We took a root out of this equation, and we got that CQ equals to the square root of 36. The square root of 36 is 6. So we found out that CQ equals to 6 units. CQ equals to 6 units, and we know that QCEF is a rectangle because of the fact that it has 4 right angles, and the opposite sides of a rectangle are equal to each other, so QC equals to EF. QC equals to EF, but we just right now found out that QC equals to 6, so from this equation QC equals to 6 equals to EF, we will derive that EF also equals to 6. So EF also equals to 6 units, and we know in the next step we drew perpendicular from point C to OM, and we define the touching point between the perpendicular from point C to OM as point U, and there we know that quadrilateral UCMF is a rectangle. Why? Because first of all it has 3 right angles, and any quadrilateral that has 3 right angles, it must be a rectangle. Okay, so quadrilateral UCMF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. Okay, 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 so here we know that quadrilateral UCMF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, MF equals to UC, MF equals to UC, but we just right now found out that UC equals to x plus 6. We just right now found out that UC equals to x plus, because of the fact that QC equals to 6, then use and here UQ equals to ME, so UQ equals to X, so UC equals to X plus 6. UC equals to X plus 6, therefore MF must be also equal to X plus 6. MF equals to X plus 6, and here we have what is the value of UO. The value of UO is actually equals to OM minus UM. Again, UM, these small line segments, minus minus OM minus UM equals to OU. Okay, so OUO equals to OM minus UM, but OM equals to Y according to our definition, and UM equals to 1 unit, therefore UO equals to 1 Y minus 1. And what is the value of OC? The value of OC, O is the radius of the biggest circle, and C is the radius of the smallest circle, and they have an internal length between them, and the distance between the radiuses of 2 circles that have an internal length between them is the difference between the lengths of the radiuses. That is to say, it equals to the radius of the biggest circle, that is 1, minus the radius of the smallest the radius of the biggest circle, that is capital R, minus the radius of the smallest circle, that is minus 1. So in conclusion, we got that OC equals to capital R minus 1. OC equals to capital R minus 1. So in triangle OCU, in the right triangle OCU, according to, in this right triangle, in the green color, OUC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OC, that is R minus 1, equals to OU square plus UC square. OC equals to R minus 1, so OC square is R minus 1 square. That equals to OU square, that is Y minus 1 square, plus MF plus UC square, that is actually X plus UC square, that is X plus X square. Okay, so we got this equation. We opened the brackets of this equation. We found out that here this first equation equals to R square minus X square minus Y square, that equals to 2 times R minus Y plus 36 plus 12x, and according to equation number 2, R square minus X square minus Y square equals to 18 times R minus Y, and according to equation number 1, R square minus X square minus Y square equals to 8 times R minus Y plus 144 minus 24x. Okay. Then we compare the equation number 1 to equation number 2, and we got this equation number 3 that says that 18 times R minus 1 equals to 8 times R minus Y plus 144 minus 24x, and we open the brackets here. Here actually we subtracted 8 R minus Y from equation number 4, and we got that 144 minus 24x equals to 8 times R minus Y. Here we divided this equation number 4 by 10, and we got that R minus Y equals to 144 minus 24x over 10. Here we divided both the numerator and the denominator by 2, and we got that 144 over 2 is 72, and minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion, we got that according to equation number 4, R minus Y equals to 72 minus 12x over 5. Then we created equation number 2 by comparing equation we created equation number 5 by saying that equation number 2 equals to equation number 3, y equation number 2 equals to equation number 3. Equation number 2 is R square minus X square minus Y square, and equation number 3 in one side also has the same expression, that is R square minus X square minus Y square. So we can compare equation number 2 to equation number 3. Okay, so those two sides will be equal to each other. Okay. So we got this expression. We open the brackets here. And here we actually subtracted 2 times r minus y from this equation number 5. And we got that 36 plus 12x equals to 16 times r minus y. Here we divided equation number 5 by 16. And we got that r minus y equals to 36 plus 12x over 16. And we divided both the numerator and the denominator by 4, and we got that 36 over 4 is 9, 12 over 4 is 3, 12x over 4 is 3x, and 16 over 4 is 4. So according to equation number 5, r minus y equals to 9 plus 39 plus 3x over 4. This is according to equation number 5, but according to equation number 4, we have already found out that r minus y equals to 72 minus 12x over 5. So we can write down that r minus y according to equation number 4 equals to r minus y according to equation number 5. That is to say, 72 minus 12x over 5, this is r minus y according to equation number 4 must be equal to r minus y according to equation number 5. That is actually 9 plus 3x over 4. Here we cross multiplied equation number 6. And we got that 4 times 72 minus 12x equals to 5 times 9 plus 3x. Here we open the brackets on both sides of equation number 6, and we got that 2 times 72 is 128, 2 times minus 12x is minus 40x, minus 84x, 4 times 9 is 45, 4 times 3x is 15x. So conclusion, we got that according to equation number 6, 288 minus 48x equals to 45 plus 15x. So here 288 minus 45 is 2, so 243. That is to say, we subtracted 45 from this equation number 6, and we got that 243 equals to here 48x plus 15x is 63x. So in conclusion, we got that according to equation number 6, 243 equals to 63x. We divided this equation, we divided this equation by 63, and we got that x equals to 243 over 63. We divided this both the numerator and the denominator of this number by 9. 244 over 9 is 27, and 63 over 9 is 7. So in conclusion, we got that x equals to 27 over 7. So then according to equation number 5, r minus y equals to 9 plus 3x over 4, but so here we can substitute x by 27 over 7, because x equals to 27 over 7, according to equation number 6. Okay, so we substituted x in this equation number 5, by 27 over 7, and we got that r minus y equals to 9 plus 3x, and x equals to 27 over 7, so r minus y equals to 9 plus 3 times 27 over 7 over 4. Okay, so r minus y equals to, here we have 3 times 27 is 81, so we have here 81 over 7, over 4 is times 4, and we multiplied 9 by 7, and then we divided by 7 in order to have a common factor with this expression. So 9 times 7 is 63, so we have here 63 over 4 times 7. So here r minus y equals to 63 plus 81 is 144, and 4 times 7 is it is 4 times 7. Here we divided both the numerator and the denominator by 4. 144 over 4 is 36. So here 4 will get cancelled. So in conclusion, we got that according to equation number 5, r minus y equals to 36 over 7. Okay? This is according to equation number 5, but according to equation number 2, we have already found out that r squared minus x squared minus y squared equals to 18 times r minus y. So according to equation number 2, here we can get r squared minus y squared equals to r plus y times a minus y, according to the trigonometric identity, according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. So we got that this equation equals to r plus y times r minus y minus x squared, but x squared equals to 27 over 7, so x squared will be equal to 27 over 7 squared, and it equals to 18 times r minus y, but we have already found out that r minus y equals to 36 over 7, so we can substitute r minus y by 36 over 7. So we did it, we got this expression that r plus y times r minus y times 27 over 7 squared equals to 18 times 36 over 7. So here we got that here we substituted r minus y by 36 over 7, and we got that r plus y times r minus y is 36 over 7, and it equals to 27 over 7 squared plus 18 times 36 over 7. And here we got according to equation number 2, r plus y times 36 over 7 equals to 27 over 7 times 27 over 7 times 18 times 36 over 7. Here we multiply the equation number 0 by 7. So we got here, so here 7 will get cancelled, and we left only with r plus y times 36. And here we have in the numerator 7 times 7, so 1 7 will get cancelled, and this expression equals to 27 times 27 over 7, because 1 7 will get cancelled because we multiplied the equation by 7. So here we multiply this equation by 7, so 7 will get cancelled here, and we left only with 18 times 36. So here r plus y, we have here r plus y, so we left here with r plus y times 36 times 27 times 7 over 7 times 18 times 36. Here we divided this equation by 9, so 36 over 9 is 4, so we left only with 9 times r plus y. And here 27 over 9 is 3, so this expression equals to 3 times 27 over 7. And here 18 over 9 is 2, so 2 times 36 is 72. So we got that r times 4 times r plus y equals to here 3 times 27 is 81, so it is 81 over 7. So here we multiplied 72 by 7, and then we divide it by 7 in order to have a common factor with this expression. So in conclusion, we got that 81 plus 7 times 72 over 7 equals to 4 times r plus y. Okay? So that is to say 4 times r plus y. Here 87 times 72 is 504. So we got in the numerator 84 plus 81 plus 544 over 7. Here we 81 plus 504 is 585. So we got that 4 times r plus y equals to 545 over 7. Here we divided this equation number 2, by 4, and we got that r plus y equals to 585 over 4, but we have here in the denominator 7, so 7 times 4 is 28. And here we got the equation, according to equation number 2, r plus y equals to 585 over 28. But according to equation number 5, r minus y equals to 36 over 7. So here we add equation number 2 to equation number 5. Equation number 2 plus equation number 5. So r plus y plus r minus y. R plus r is 2r, and plus y plus minus y is 0. So 2r equals to 585 over 28 plus 36 over 7. But we multiplied both the numerator and the denominator by 4. 4 times 36 is 144, and 4 times 7 is 28. So in conclusion, we got that 2r equals to 585 plus 144 over 28. 535 plus 144 is 729 over 89 equals to 2r. We divided this equation by 2, and we got that r equals to 729, and 2 times 28 is 56. So in conclusion, we got that the radius of the biggest circle is equal to 729. That 729 over 56. That is it is less. It is more, a little bit more than 13. That is to say, it equals to 789 over 56. It is actually 13.017 or 13.018 equals to 13.018 units. So in terms of numbers is 729 over 56 units. Okay, so the radius of the biggest circle is equal to 729 over 56 units, or either it equals to 13.018 units. Okay, thank you very much.